All right, good morning, everyone. My name is Andrew Kemp. I am a recent graduate of McGill University, and this summer I conducted some research at UE St. Augustine with the TT Lab on improving multidimensional vulnerability indices. All right, so as you know, the Caribbean region is uniquely situated such that it is affected by climate change more so than any other region in the world. However, it has contributed to basically none of the problem that it faces. So we want to know how we can assess the vulnerability of the region so that we can allocate aid, resources, funding, and attention to the areas in the region most needed. So vulnerability and resilience are important concepts to consider so that we can determine which areas are most vulnerable and how resilient they are to natural disasters and climate effects. So in the past decade or so, the Multidimensional Vulnerability Index was developed in order to measure these concepts while considering a multitude of the different factors that are relevant, such as socioeconomic data, population data, environmental factors, and regional geographic data. So the MVI is an improvement upon other indices that have existed that have considered less of the environmental variables, but more so just economic data. So as we move away from more GDP-based measures of vulnerability, we turn to this tool that has been recently developed. So the CDB in 2019 published their Multidimensional Vulnerability Index, localized to 19 countries and states in the Caribbean, and they use 15 indicator variables across 6 categories to determine which of these factors are important in predicting the vulnerability of a region. As you can see, they involve a lot of economic, export and import type of factors, some social indicators, and then climate change and natural hazards. And they also explore various weighting schemes which place the different indicators of different levels of importance. And these are the countries that are being considered for my study due to data limitations for some of the smaller territories. And then the UN's MVI was developed a couple years after the CDBs, and it was originally developed as a tool for small island developing states. And in the UN, they considered the entire globe with 26 indicator variables with various different categories of vulnerability and resilience. There are several issues along with areas for improvement between the indices that they have made, such that the selection of indicator variables is somewhat subjective. They do take into consideration expert opinions. However, a lot of them are not as data-driven as we at TT Lab would like. So we think that there can be some more empirical evidence to include certain variables and weight them accordingly to how important they are to vulnerability. Likewise, across many different indices that measure vulnerability, there was a comparison of how many of them contain similar variables, and they highly lack uniformity, such that all the different indices, they have completely different indicator variables, all trying to reach the same goal. So we want to try to combine them so that we can figure out which indicators are the most relevant to the situation in the Caribbean. And then another problem with the MVIs are that they are somewhat inefficient in how they gather data and compute their scores. So at TT Lab, we focus on AI and machine learning, and we wanted to take a data science approach to improve them. So we applied some regression analyses, some supervised and unsupervised learning models to try to optimize and simplify the indices that they have made. So we used regression, which will tell you the score of how accurately our machine learning models are at predicting the vulnerability of a state. And then PCA analyses, which will give us clues on which variables we can weight more highly or disregard. So from our initial regression screening, we found that among the dozen of models that we tested, they all perform very highly with R-squared values of over 0.9 and very low mean absolute errors as well. So this is a good sign that these tools can be used to predict vulnerability scores. So for this, we tested along the data gathered from the CDV and the UN, and we aggregated it and cleaned it and are using it to test which models are best. And then we also use the strongest regression models. In this case, we're using ARD regression, which is a certain format. And this method is, it produces the feature importances of the different variables. So for the CDB data, we can see that the total number of deaths and the total number of people affected by natural disasters are the two most important variables in the model that can predict the vulnerability of the country. So that is seen on the two bars on the right hand of the graph. So 40% of the model is accounted for by these factors, while some of the more economic factors, such as tourism or remittances, are not very good predictors or not very important in the model for looking at vulnerability. And then for the UN MVI, we looked at the two most important variables that we found in this model, being population size and renewable internal freshwater resources, about 10% each of the weights towards determining the vulnerability score. So that accounts for about 20% of the 26 different indicators. And then if you look in this box, these are the features associated with natural resources and environmental factors, and you can see that they contribute way less to the model. So there are many factors to consider in the MVI, and it's not always intuitive that climate variables are the most important predictor of climate vulnerability. And then from our PCA analysis, which is a technique to reduce the dimensionality of data, we can see that 8 of the components account for 85% of the variation in the data, and 11 components account for 95% of the variation in the data. So this may indicate that we can simplify our models, our MVIs, to include less indicator variables, as there were 15 variables that are being considered and weighted, but around 4 of them could be discarded, and we can still preserve 95% of the variance explained. So we can save information, we can save simplicity and gather less data and still produce a 95% accurate result. And then these are the PCA loadings of the analysis, and we can see that, again, we have unemployment in U, natural disaster deaths, and natural disaster affected. these have the highest magnitude, meaning they are most responsible for the variance of the data. So we would look at these factors as having a higher weight for how we would score the vulnerability index. And then we also have tourism and destination of exports as responsible for a lot of the vulnerability as well. And then likewise with the UN data source, we saw that 19 of the components can account for 95% of the variation within the data. So this is 6 indicator variables less than than what they use in their index. So we think that perhaps they could optimize it so less factors are considered while still preserving a lot of what we find. And then looking at which variables led to the most variance in the data sets, we have some social factors, some environmental factors, and also some population statistics as well. So generally, we find that machine learning models are very promising in leading to more predictive models of which countries, regions, areas in the world are most vulnerable to climate change, and we can also assess which of the specific factors are the most important and determine vulnerability so that we can treat those areas and give priority and allocate funding where it is most needed. And as I'm sure you may know, there is a lack of data in the Caribbean that is used to inform these models. So in the future, we do need to work towards gathering more data and exploring additional methods of how we can assess vulnerability. So I would like to thank everyone for your time, and there we go.